the power and energy signals. So this is a very interesting topic, classification of discrete time signals into energy signals and power signals. So let's go right in there. Starting with energy signals, very simple definition. Energy signal are those signals which have finite energy. So if E is between 0 and infinity units, then the signal will be called as finite as energy signal. Okay, now how to calculate the energy? We know it's a very simple process. You have the signal itself, you take the magnitude. Now look, keep looking at this equation. So I like to convert the equations in the verbal form so that the formula is easier to remember. Okay, so I'm starting again. So we have the signal xn, we take its magnitude. So all the signal values gets their absolute values, then those values are squared. Okay, and then there is a summation from minus infinity to plus infinity. So this means that whatever the signal is, you simply take its magnitude, you square all the values, and you sum all those square values, and you will end up with one number that will be the energy of the signal. So it's a very simple formula to calculate the energy of the signal. So this is expanded into this form. So this is coming from minus infinity. You arrive at x equals x of minus 1 magnitude is squared, this x of 0 magnitude is squared, plus x of 1 magnitude is squared, and this continues on, and this gives you the energy of the signal. Now it will be easier for you to understand through this example. Now this figure, this slide has 4 plots. So one is table, the second on the top right, this is the value of xn. So let's start from here. The value of xn is minus 1, minus 2, 3 and 4, and on the left hand side it is 0, on the right hand side it is 0. So for n equals to 0 it is minus 1, for n equals to 1 it is minus 2, for n equals to 2 it is 3, and n equals to 3 it is, the value is 4. And in this table, the first column is n, starting from minus 2 going to 6. The second column is the value of xn. At 0 it is minus 1, at 1 it is minus 2, 3 and 4, and for all other values it is 0. So now what we do is, as we mentioned earlier, that we take the magnitude of these signal values. So what happens is that 0 remains 0, minus 1 becomes 1, minus 2 becomes 2, 3 becomes 3, 4 remains 4, and 0 remains 0. Then we take a square of the signal magnitude. So 0 remains 0, 0 remains 0, 1 remains 1, 2 becomes 4, 3 becomes 9, 4 becomes 16, and then all 0 remains 0. So these are the values of x and magnitude squared, and then we sum all of these values. So from minus infinity to plus infinity, you end up with 1 plus 4 plus 9 plus 16, so you get to the energy value of 30. So graphically, this was the signal xn. We take the magnitude, we get to this point where minus 1 becomes 1, minus 2 becomes 2, 3 and 4. Then we take the square, so 1, 4, 9 and 16, and then we add all these values. We end up as 30 units, and 30 is a finite number. So we can say that this example, this is an example of an energy signal. Okay. Similarly, it's now you can simply visualize, and without maths you must be able to find out whether the signal is an energy signal or not. So if we take an example of a unit impulse signal, unit impulse signal is a signal which is delta n, and it has got only one value of 1 at n equals to 0, and it is 0 otherwise. So just visualize that if you take the magnitude of this signal, it remains the same. if you take the square of this entire signal, square of 1 is 1 and the square of 0 is 0, so we still get the same signal, and then we sum all the values from minus infinity to plus infinity. So we have all the zeros and just one value of 1, so the sum will be 1. So if we just what I just described in words, if you want to look at it in a mathematical format, it is all given here, and it is 0 plus 0 square plus 0 square plus 1 square plus 0 square plus 0 square and so on. You end up as 1 unit. So the energy of a unit impulse signal is 1 unit, and this is a energy example of energy signal. Okay. Similarly, if we want to try and see the energy of a unit step signal, this is a unit step signal. It has 0 values for n less than 0, and it has value of 1 for all the values on the n equals to 0 and positive values of n. The value of the signal is 1. Now conduct the same exercise. Take the magnitude. The signal remains same. Take the square of all these values. So 0 remains 0, 1 remains 1. Now the last step is to take the sum of all the values from minus infinity to plus infinity. Okay, till this point, all the negative values of 0, till where the values of the signal are 0, you sum them up, you get a 0. But now on the n equals to 0 and positive values of n, these ones do not stop till infinity. So it's very easy to see that if you add an infinite number of ones, then the answer will be infinite. So this is what's happening in here, that when you do the maths, you end up as infinite amount of energy. So unit step signal is not an energy signal. Okay, now let's look at what are power signals. So the definition is very simple. Power signals are those signals which have finite power. So just like energy signals were those signals which have finite energy, the power signals are those signals which have finite power. And if we understand the concept of power signals, then it will be easier for us to understand the equations and remember them. So what is the first thing to remember? The first thing to note is that power is the rate of energy. That is, power in very simple terms is energy upon time. Okay. So when we say it is energy upon time, it means that you have to find out whatever the energy of the signal is and then divide it over all time. So in terms of discrete time signals, what we are essentially saying is that if you have got a signal, then you first of all find its energy, whatever its energy is, in the very same manner in which we find energy, and then spread that energy equally to all samples. Now when we say all samples, it means we are talking about infinite number of samples from minus infinity to plus infinity. So we have to spread that energy equally to all samples and then see how much energy each sample has got. So this will be the power of that signal. So it's energy upon time, energy spread evenly across all samples. Now, given that explanation, it will be a bit easier for you to understand this equation of power. You must remember that the energy was this formula, except that the limits were minus infinity to plus infinity. Right, so let's just start from the xn. So you have got the signal xn. You take the magnitude as in the same manner you take in energy. You square those samples. This is also the same in, pattern. And then we sum everything up from a number minus n to plus n. Okay, Now this can be minus infinity to plus infinity, and essentially we want it to be minus infinity to plus infinity. But in most of the cases, like we saw in step signal, if we do minus infinity to plus infinity right here, then this summation will end up being infinite itself, and we will not be able to proceed any further. How can you divide an infinite amount of energy to even samples? You won't get an answer. So mathematically what we do is we take a limit, lower limit of minus n and the upper limit of minus n plus n. So it means essentially we are talking about 2n plus 1 samples here. So from minus n to minus 1 there will be n number of samples, and then from 0 to n there will be n plus 1 samples. So n plus 1 is 2n plus 1. So we take the energy of the signal from minus n to plus n and we divide it by 2n plus 1. So we are getting an average of the energy for all 2n plus 1 samples, and then we apply the limit n tends to infinity. So it's like spreading the entire energy to all samples and see how much energy each sample gets. So this will be your average power. This will be the power of the signal, and if this number comes out to be finite, then this is a sign of a power signal, and this expression is expanded in this form. So everything else remains same. The summation from minus n to n is now expanded to x of minus n whole square plus x of minus 1 whole square plus x of 0 whole square plus x of 1 whole square, and so on till x of n whole square. So these are 2n plus 1 samples, so that's why I divided them by 2n plus 1, and then we apply the limit n tends to infinity. So now what we are going to do for a unit impulse and a unit step signal is that without using the math, using intuition, let's try to see what are the power and energy of the signal. So this is a unit impulse signal, and if we try to figure out what its energy will be, so we take the magnitude of the signal remains 1, then we square it, so we again get back the same values, and then we sum everything up. So when we sum everything up from minus infinity to plus infinity, we will get 1. So this is an energy signal with 1 unit. And now if we want to spread out evenly this 1 unit to all samples evenly from minus infinity to plus infinity, it is very easy to see that for every signal the average value will be 0. It is obvious that if you try to spread out an even number, whether it is 1, it is 100, it is 1000, it is a million or a billion, try to evenly distribute a finite number to infinite number of samples evenly, then we will be getting a 0 for all number of samples in average. So this indicates that this is an energy signal with 1 unit of energy, and its power, if we calculate its power, we are bound to get 0 power because of this description that when we spread out a finite amount of energy to infinite number of samples, we get to a 0. And this is the mathematical explanation of what we just described. These are the same formulas. We must note that this is the sum of energies, individual energies of all impulse values, and because only delta 0 will be 1 and everything else will be 0, so this summation will give us 1. So it will be 1 upon 2n plus 1, applying the limit which is explained here, and we will get to 0 units. So the average power of the impulse will be 0. Now let's look at the unit step example. Of course, the energy is, we have seen it as energy is zero, is infinite. But now let's try to see the power. What will be the power? It is important to note that half of the samples towards the negative side of n are 0, and half of the samples towards the right side of yn, of y-axis, or positive n, are 1. And so so you can imagine that half of the population has got 0 value and half of the population has got 1 value. And when you take the absolute and square it, you still get back the same signal. But then when we try to spread the energy to all samples evenly, then because half of the population has got nothing and half of the population has got 1, so when we spread it evenly across all samples, we must end up at half. So it is expected that if we try to compute power through the mathematical formula, we should get half as the answer. So with this intuition, let's see how the maths works. And here we see everything is the same. This is the signal, this is the formula, and we expand this up. And now here you focus from u of minus n to u of minus 1. They will all be 0. And from u of 0 to u of n, these are n plus 1 numbers. So this will be 1, this will be 1, everything will be 1 till this point. So what we are saying is that add these number of ones, so we will get n plus 1, because half of the population is 0, and from 0 till n we have got 1, so the total will be n plus 1, and divided by 2n plus 1, and applying the limit n tends to infinity. So because we can simply, before applying the n, we can take n common from the numerator and denominator, ending it up as 1 plus 1 over n upon 2 plus 1 over n. N gets cancelled with n, and when we apply the limit, n tends to infinity, so these 1 over n and 1 over n get 0, and we end up as half unit. So it is easy to see that using the intuition we are able to estimate the power of a signal. So in this case we have finite power and infinite energy. So a unit step signal is a power signal, not an energy signal. And similarly, you can see that this is an example of a unit ramp. The energy will be infinite, as well as if you try to spread evenly the energy to all samples, still because this is rising, we will not be getting any finite answer for this signal. Mathematically as well, we end up at infinite power. So this is a unit ramp signal is an example of a signal which is neither an energy signal nor a power signal. So in summary, if energy is finite, then the power will be 0. If power is finite, then obviously you collect all the power from all infinite samples, then obviously energy will be infinite, as we saw in the unit step example. And if energy is infinite, then its power may be finite or infinite. Just like in ramp, the energy was infinite and the power was infinite as well. And similarly, if the power is infinite, then we will have to calculate, then we can through intuition expect that its energy will also be infinite. So a unit impulse signal is an energy signal with 0 power. A unit step signal is a power signal with infinite energy, and a unit ramp signal is neither an energy nor a power signal. So today we have reviewed what is a discrete time representation of some elementary signals, and we have also covered power and energy signals, and these are the readings from your chapter 2 introduction, section 2.1, section 2.1.2 energy and power signals. So when you go through the readings and watch this lecture, then I'm sure these will be very clear and easy concepts, and we can discuss more in the live session when we meet next week.